Hey, it's our Paralyzed Math and History, and we are going to take a look at the distance formula. So, to warm things up a bit, what we're going to do is try to solve a problem using the Pythagorean theorem. Remember, the Pythagorean theorem has this formula, a squared plus b squared equals c squared, where a and b represent the legs, and c represents the hypotenuse. So, we have the problem right here. Ooh, it's an XY graph. What's going to happen? So, what's going to happen is our goal is to try to find the distance between this point right there and that point right there. So, we're going to draw a line from that point to that point. A straight line. But the problem is, how are we going to find that line? What we can do is we can find the slope between the two, but we're not trying to find the slope of the line. What we're trying to do instead is find the length of the line in terms of distance, like inches, feet, 26 inches, 26 centimeters, something like that. So let's use the Pythagorean theorem to solve it out. So we have the coordinates 4 and 8. If you ever realize that if you go from here to here, if you use 4, 8, what's going to say is if I go directly down, it's going to say 4. That is going to be our x. And if I say 8, that's going to appear right here, y as 8. If I make another line using the red marker, if I say 12 and 2, right here is going to be 12 on the x-axis, and right here is going to be 2 on the y-axis. And turns out that this triangle that we just made happens to be 90 degrees. A right triangle. But the problem is, how do we know what this green line is? Or how do we know what the hypotenuse is? That explains why we circled the c squared in green, because that's our goal. Well, what we can do is find the length between here and here, and the length in units between there and there. 12 minus 4 is going to be 8. So right here is going to be 8 units. 8 minus 2 is going to be 6. So this is 6. Hey! Why don't we try and draw this somewhere else? So right here, we've drawn the triangle and got it from here to there. Let's do the Pythagorean theorem. So 6 squared plus 8 squared equals whatever this thing is squared. Then we have to do 36 plus 64 equals 100. Square root that 100, x is going to equal 10. So that question mark hypotenuse is going to equal 10. Whew! That is a lot of work. And we did a lot of steps to even find out that this was a right triangle. Not only that, but we also did a lot of work to even find the length between 4, 8 and 12, 2. But how do we do that in just one formula? Well, the distance formula is going to help you because all you have to do is use the formula and it gives you an express way to find this length right here without doing all this clutter work. So, when you think about distance, this is probably what you might think of. Something like measurements or feet or blah 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 maybe. Well, the actual formula is right over here. So here is the distance formula. Your distance is going to equal the square root of everything inside of here. And it looks like we have x2 minus x1 squared plus y2 minus y1 squared. And when you do that, you're going to get the length of what your distance is. The length of what that green line is. So we're going to try to start over the problem, but we're going to insert these into the distance formula. So remember, distance is going to equal the square root inside of everything, x2 minus x1 squared plus y2 minus y1 squared. So if we try to plug in the numbers into this formula right here, we can understand what the distance is. Remember, the first step we have to do is plug in the numbers in here, the coordinates of them. So we have the second x minus the first x squared. So we're going to pick some numbers. We are going to say that this is going to be coordinate number 2, and coordinate number 1. Since it looks like a negative slope. So here's what's going to happen. We are going to say 12 minus that by 4. That is because 12 and 4 are x's of both of the equations. And if we go on to the other part, we have to do the second y minus the first y squared. So what we're going to do is write 2 right here minus that by 8. So that is because we have 2 right here and 8 as the two different y's. So both of them have 2 and 8. Now we can start deducting and we can start simplifying to get what d is alone. So the first thing we have to do is do the stuff inside the radical. So we have 12 minus 4 squared plus 2 minus 8 squared. What that will transform into is 12 minus 4 is going to be 8 squared. And 8 squared is 64. 2 minus 8 is going to be, parentheses, negative 6 squared. And a negative times a negative is a positive. And that is going to bring us 36. So now, here's what the equation looks like. Our d is going to equal the radical, the giant radical, maybe. And then we have to do 64 plus 36. And when we do 64 and 36, we are going to get 100. So here is the final home stretch. D is going to equal the radical of 100. And the radical of 100 is D equals 10. So we got this thing done a lot faster. And we also came to the same conclusion that this is 10. So we did this in the first part of the video. We got 10 alright. But we also did the distance formula. And we also got 10 right here. So doing the distance formula is a lot faster and will give you the express way to only find the length of the hypotenuse if you only have a graph. You can't really find it unless you have a graph because there are x and y coordinates in the formula. Did you also know that the distance formula is basically another setup of the Pythagorean theorem? So the Pythagorean theorem came first, but the reason why the distance formula is similar is because it's literally saying everything set out. So basically, they expanded the entire equation or the formula and put all of the information without simplifying one step. So you're basically doing all of the information at once. Haha! And that completes the video. I hope this video has helped you understand distance formula. Thank you for watching Tao Ping Live's Math Industry. Like and subscribe.